We'll be looking at the elevation. What you would do first of all, you are going to set your paper. Everybody got a paper like this, right? Now when you're doing elevations, you must do all four sides of the building. So you go outside, you look at what you see, and you draw exactly what you see, right? With the elevations, you are using your floor plan to extend your lines for your windows, your doors, and all of the external features that you will see on the building. So hence I gave you a list of some of the features that you will see on an elevation. Not all of them you will see depending on the drawing that you're doing. If there is no veranda, then you would not see veranda. Some elevations you will only see probably windows alone, maybe doors alone, maybe a window and a door, but you may not see all of the list that is there on the board, on the wall. So elevations basically are upright, vertical views of the building looking in the four directions of the building. So it is basically vertical, upright views where you're able to see all of the external features of a building. So when we say the external features, you're not concerned about what is happening inside, but whatever you see on the outside. So you see things like your windows, your doors, if you see skylights, if you see balusters, verandas, all of those things are outside, and you may see some of the other lists that I did not call, but all of these are external features of a building. Right, now when you're doing the elevation, so for your SB as well, you will be required to extend the lines from the floor plan. Now each side that you're doing the elevation from, you must rotate it. So we do the back here first because I want you at least be able to understand. It doesn't matter which side is done first, right? It doesn't matter which side is done first. So you are going to turn your drawing upside down. Turn your drawing upside down. You're going to stick your paper up at the top of your drawing board. So you're going to stick that paper that I just gave you up to the top, right up. So right at the top. Still try to align it. Now this drawing was done without T-square. So I did not use T-square and set squares and so on to do them. So some of the lines may be a little off, but I'll try to explain. When you're doing the angles again, it may be a little off because I did not use T-square and so on to do this. Now get your exercise book and I want you to quickly sketch. I don't want it to take forever. You're doing a freehand sketch of each of the sides that I'm going to be showing you. Whatever you see. Whatever you see, so I'll do it. Right, so I'll start on this side. So get your exercise book so that you can do some sketching. I want to elevate it so at least you will see one particular thing. I don't want you to see both two sides. I want you to see only one side at once. So I don't want you to see both sides here and here. I want you to just focus on one side alone and draw exactly what you see with it one side. Quickly, don't take forever. This will not be marked. It's just for me to be able to explain to you what they are. I could have elevated at the top so that everybody will see the same thing. switching sides. In a few minutes, I'm switching a side, another side. So no ruler, don't use ruler. That will take too long if you use ruler. So just sketch exactly what you see. So I'm switching. Next side. I'll finish. Alright, next side. So you'll be able to see. Finish? Concepts that I have on the board. Right, so with elevations, there are some of the things here that you will see. So the first thing is, for the slope of the roof here, so on your drawing, you're going to name it as roof slope. So whatever your drawing looks like, I know at least somebody saw this set. Right, so anybody saw this? That slope? Right, so that's the slope of the roof. The slope of the roof can be any degree, 18 degrees, 22 degrees, 22 and a half, 30 degrees, etc., etc. Right, so you put this here will be the slope of the roof. This here is called the fascia board. So note that, so we write that as a fascia board. Fascia board. I'm sure person saw window. Right, so this is your window. But this part here we'll call the window level. You saw any door? That elevation had a door? Yeah. Any one of them had a door? Yeah. Right, so we just chuck it in here. So this here is the window or the door level. Window or door, line or level. So some text you will see it as level, some you will see it as line. This here is your wall. So question, with this elevation or any of the elevation that you drew, did you see thicknesses of walls? Right, because if you're outside of the building, you cannot see the thickness of the wall, right? So let's establish that you would not see thickness of the wall. You had a bottom, right? Good, so I'm sure nobody extended anything here. So if you did not, you need to extend because your building does not need air in midair. Alright, so you'll extend. And this here now is called the ground level. Ground level. Ground level. I didn't give you any elevation with a veranda, so we'll leave that out for now. This at the bottom here, so where your door is placed, it means that there must be a floor. They must have a floor, right? So you must have a floor. So that level here is either your floor level or your finished floor level. So I'll explain the difference with floor level and the finished floor level. So you can name this here as your FFL, FFL or your FL, finished floor or your floor level. At the top of your windows and your doors, so top of windows and doors is where you will see a lintel. I'll explain the lintel line later on. Yeah, FFL, finished floor level or floor level. So that line here will be our floor level or finished floor level. Now when we start the drawing, I'm going to explain the concept of this line. This line here should not be a solid line, because if you're outside of a building, unless your building is transparent, if it's glass, then you will see the floor. If you're outside, you cannot see the floor. Only if there's a door, you know, okay, that is where your floor level will be. Alright, but another elevation where there is no window, you cannot show a floor level there. Alright? However, on all of the drawings, then you must have a floor level. So this here will be dashed line, but we talk about that when we actually start the AutoCAD one. The other one is what you call a ring beam or belt beam, or sometimes they call it a perimeter beam. So when you look at the top, you see that recess. Inside there has reinforcement in order to be able to support the structure at the top. So that one's a concrete. So this inside here now will be what you call a ring beam. Ring goes around your finger, belt goes around your waist, perimeter is the distance around. Alright? So those three terms here can be used when you're talking about buildings. So you have ring beam, belt beam, perimeter beam. Now that beam, that distance from floor level to the top here will be the distance when we measure from this point, from the floor level, right up to the top here. So right at the top here, at the top area, this portion will be the ring beam. Ring beam, belt beam, perimeter beam. So I think we kind of covered, as I said, you wouldn't see the veranda just yet. Yes, so let's see if we can start and understand how an elevation is done. So at the bottom, as I said, at the bottom of your drawing is where you're going to do now your floor plans, elevation. So you have the floor plan at the top, and then from there we're going to extend our line to give us our width and so on. Now none of the widths are taken by measuring. We simply extend them, right? So let me take this up. So you should have another drawing, plain paper at the bottom, so that we can start this elevation. Now when you're doing elevation, you must start off with a ground level. So draw a horizontal line at the bottom that will represent your ground level. So at the bottom, that's on the second drawing sheet of paper. So you have your drawing sheet of paper here. That is what you're doing for your elevations for the SBA. So that is your ground level. And the ground is continuous, so your line should be longer than that of your building. Right, so I'm going again. So that the line at the bottom represents my ground level, or the ground line. Some text has it as a ground line, some has it as a ground level. Now I'm going to extend here now. Now I'm focusing on the building before I look at the roof. Right, so I'm focusing on the walls only. Right, I'm leaving the roof off for now, so I'm taking all of my walls. So I'm going to extend. As we said, when you stand on the outside, what you will see is the end of the building. So you will not see wall thicknesses, so you do not pull down the two lines here to show your wall thicknesses. So when you draw, you're going to extend that line or draw that line down, and you will see that your building is resting on the ground. So your line is going down to your ground level. So draw that line for me. So this here, put your set square on the T-square, and you want to extend your line. That line is going to go down to the ground level. I'll do the same thing on the other end. So I'll do the same thing on the other end. So I'm extending my two lines from the floor plan. So that's what will be happening for the SBA. You must extend the line from the floor plan. On the computer, you have your floor plan. All you do now is extend your lines from there. So you do your ground level, then you extend your line. You extend your line to show the ends of your building. Next. Now from the ground level to the floor level, that is where you're standing. So the floor level, that's outside, sorry, the floor level to the ground level outside. That height we are using, so for the SBA and for residential buildings, the building is flat, we tend to use 2 feet, which is 600 millimeters. So we will do the same thing here. So on your ruler, you are going to measure 1.5 centimeters from it. On your ruler, you're measuring 1.5 centimeters. That line will represent your floor level, sorry. So that line will represent your floor level. So I'm going to write here now, FFL dot. Now FFL means that your floor is tiled. Alright, it is finished when it's tiled. If it is just finished, it means that it's untile. Right? So finished floor level means that your floor is tiled. And most persons, when they build, they want their floor to be tiled. Right? So that distance we are measuring as 1.5 centimeters. So that height in millimeters. So when you do it on your AutoCAD, this height here now will be 600, so you can write those as you go along. 600. So that height here, 600. So let me write from floor level, from when we say FFL, finished floor level to ground level is 600.